All right, yeah, let's talk about a few graphs of common functions. It's going to be handy to know if we look at a function and see a particular type of operation or whatever it is, to know what the graph of that common function looks like. For example, we talked about one of them, the f of x equals mx plus b one. That's a common function, and we should know that the graph of that is a line, right? We mentioned that one earlier, so yeah. This is the linear function, graph's a line, slope m, y-intercept b. Okay. So that's the type of thing. We should know a little bit about some of these, and that one we know a lot about. So that one's a nice one. Okay. Number two, though, some others we should know a little bit about, and we'll talk a lot more about them as we go along. But yeah, if we have an f of x equals x squared, we should at least know a little bit about the shape, and so that's the kind of thing we're getting at here. Well, just going into that, maybe you know a little about it, maybe not, but we're just going to approach these graphically speaking just by table, thinking about a table here. Yeah, I think most of these, since they're not, these are just common functions, -2 to +2 should suffice. What do I get for y values if x is -2 to +2? Well, again, it's just plugging in x to be these values. So I'll get for y be -2 squared, which is +4. If x is -1, -1 squared be +1. 0 squared is 0. 1 squared is 1. 2 squared is 4. With me on that? All right, so we get -2 to 4, -2, 4. -1, 1, 0, 0, +1, 1, and 2, 4. Yeah, so we get this shape. We've seen it several times now. Bowed shape here like this. We'll talk a lot more about this one for sure. It's called a parabola. But the x squared one, yeah, this is what it looks like. It's called a parabola, but yeah, an x squared graph is always going to look very much like this. It'll move around and things like that, but that's what it's going to look like. All right, number 3, common function. Let's bump it up. Let's go to f of x equals x cubed. You know what that one looks like? Again, if you use a table here of x and y values, let's go -2 to +2. What do we get if x is -2? Well, the y value would be -2 cubed, wouldn't it? What's that going to give you? Well, -2 3 times would be 8, but -8, wouldn't it? Negative times negative times negative, -8. -1, same thing. -1 cubed gives me -1, -1, -1. It's -1. And then 0 cubed, well, that's 0. 1 cubed, that's 1. 2 cubed, that's 8. Okay? So that graph winds up looking like a little different, isn't it? -2, you got -8. That's down here. -1, you got -1. 0, you got 0. 1, you got 1. And then 2, you got +8. +8. So this winds up looking like, got a little curve to it there. Something like that, isn't it? X cubed graph. That's what it looks like. There's For x cubed, there's a lot of variation, though. We'll talk about that, though, later on. Okay? What's some others? Oh, yeah, I can do the absolute value one. What about this one? F of x equals the absolute value of x. Oh, before I forget, before I do that one, let me go back to number 2. Wanted to mention also about the domain and range. Back on the x squared one, what's your domain and range there? Domain's the x values, the range are the y values. Well, the domain, x can be anything, can it? There's no real restriction on x. All real numbers, negative infinity to positive infinity. The range, the y values, though, none drop below the y-axis, below the x-axis. So there's no y values from -1 or down. So the y values start at 0, don't they? And then go up, 0 to infinity. So in this x squared graph, that's my domain and range. What about this one, domain and range, for the x cubed graph? Better go over here. Well, the x value can be anything, so it's negative infinity to positive infinity. But because you go up and you go down, what about the range? Also, negative infinity to positive infinity. Because the y values, you got up and down, any y value you want. Okay? Wanted to mention that for you. Okay. So going back to the absolute value. F of x equals the absolute value of x. Well, we haven't talked much about absolute value, but what do you know about absolute value? Well, if I'm going x is -2 to +2, the y value then would be plug in x to be -2. The y value would be the absolute value of -2. What is the absolute value of -2? Be +2, yeah. Absolute value means the distance, basically the distance from 0, and it's always a positive, right? The absolute value. Absolute value of -2 is +2. If we plug in x to be -1, same deal. It's going to be a +1. I say absolute value is always positive. This is the one example where it's not a positive, because the absolute value is 0, 0, which is not a positive or negative number. But anyway, 1 and 2. All right, so we get all the positives, 2 to 1, 0, 1, and 2. Well, what does that translate over then to be on the graph? Well, at -2 I'm at +2. At -1 I'm at +1. Should have put that other mark there. Okay. At -2 I'm at +2. At -1 I'm at +1. 0 I'm at 0. 1 I'm at 1. And 2x I'm at 2y. Well, you can see what's happening there. These are just going to continue out straight like that. These are straight out like that. Yeah, the absolute value of x is sometimes referred to as the V-shape graph for obvious reasons. Yeah, you got the V shape. Comes together at the corner there, all right? And as far as domain and range, well, you can think about it. X could be any number here. X could be any number, couldn't it? -10, -1,000, 1/3, 2/3. X can be anything. Negative infinity to positive infinity. What about the range, though? Do I get any y value I want? Again, nothing below the negative, on the negative side, right? Only 0 and up. 0 to infinity. Okay? All right. Couple more. I'll be all done here. Number 5. F of x equals the square root of x. Square root of x. Well, this one we kind of run into our first little deal here. When going with a table, -2 to +2, run into a slight problem there, don't we? If I do -2, I get the square root of -2, and since I'm graphing this on the real number lines, axes, what about that? Square root of -2, it's not a real number. Okay, so there's not a real number here. We're doing only real numbers right now. Well, no, we did more stuff with that earlier, but right now we're talking only real numbers, so there's not a y real number value that goes with the x value of -2. Same thing here, square root of -1, it's I, but it's not a real number, so we don't get any values for those negative values, x's negative values. Square root of 0, what do we get there? Is that a real number? Square root of 0 is 0, isn't it? Yeah, 0, 0. Square root of 1 is 1. Square root of 2, is that a real number? It's a real number. It's not a nice real number, but if you punch it on your calculator, you get what? 1.414 something, something, something. Yeah, that's a real number. Now, if you look at it, this only gives me 3 points. So let's get a couple more. Let's do 3 and 4 here. If I do 3, square root of 3, well, it's like 2 there. That's not a nice square root, but is it 1.7 or something like that? Yeah, 1.73. So it's not a nice number, but it's a number. It's a real number. Square root of 4 is a nice one. Square root of 4, what do we get there? 2. Okay. All right, so here's what we get as far as the graph is concerned. Nothing on the negative side of 2 of x. 0, 0, 1, 1. 2 is 1.4. 3 is 1.7. 4 is 2. And if you want to go out to 9, we reach 3. So you can see it's a steady progression, but it's yeah, kind of the bow shape, but something more like that. Not really happy with that. Oh, okay, looks better. All right. What about domain and range on the other? Nothing x on the negative side, so it starts at 0, goes to infinity. 0 to infinity. Range, the y values, same thing, isn't it? The y values start at 0 and go up to infinity. Now it's going to take a while to get up to 10. In fact, it's 100 out there, way out there, but you do get a y value of 10, y value of anything bigger, so same thing. 0 to infinity.